My topic for today is about nanotechnology. Imagine a world where microscopic medical implants patrol our arteries, diagnosing ailments and fighting disease, where military battle suits deflect explosions, where computer chips are no bigger than specks of dust, and where clouds of miniature space probes transmit data from the atmospheres of Mars or Titan. Many incredible claims have been made about the future's nanotechnological applications, but what exactly does nano mean? But before that, here are the topics of the day. To start with, we all know that nanotechnology came from the two words nano and technology. The prefix nano referred to a Greek prefix meaning dwarf or something very small, and depicts 1,000 millionth of a meter, 10 to the negative 9. On the other hand, technology is the making, usage, and knowledge of tools, machines, and techniques in order to solve a problem or perform a specific function. Therefore, technology now is the application of the knowledge learned about tools, machines, or techniques. Then, let's focus on the definition of the word nanotechnology. It refers to the study of manipulating matter on an atomic scale. It also refers to the constructing and engineering of the functional system of very micro level, or we can say at atomic level. It means that these materials are very small that cannot be seen using our naked eye. Let's discuss now the history of nanotechnology. The idea of nanotechnology was born in 1959 when it was presented by the first ever famous professor of physics named Dr. Richard Feynman in the lecture of "There's Plenty of Rooms at the Bottom." And at the same time, this won the Nobel Prize and awarded in 1965. Term nanotechnology was been coined by Norio Taniguchi in 1974. And after that, the development of nanotechnology began. There are four classifications of nanomaterials. We have the zero-dimensional, one-dimensional, two-dimensional, and the three-dimensional. When we are talking about zero-dimensional, these nanoparticles are spherical in size, and the diameter of these particles will be in the 1 to 50 nanometer range. Example of that will be gold nanoparticle. When we are talking about one-dimensional, example of this will be carbon nanotube. These materials are long micrometer, but with diameter of only a few nanometer. The two-dimensional materials, this include different kind of nanofilms such as coating and thin film multi-layers, nanosheets of nanowalls. The area of this film can be large, but the thickness is always in nanoscale range. And lastly, we have the three-dimensional. These include bulk materials composed of the individual blocks which are in nanometer scale. We also have the different tools and technology under nanotechnology. We have the first one, which is the carbon nanotube, wherein these are the allotropes of carbon with a cylindrical nanostructure, and these are members of the fullerene structural family. The fullerene is the soccer ball shaped molecule of carbon-60. What will be the application of this carbon nanotube? Here are the applications of carbon nanotube wherein they are only self-explanatory. Then we have the nanorods or the quantum dots. Nanorods are one morphology of nanoscale objects. Dimensions range from 1 to 100 nanometer. What will be the uses of this? They are used in micro electromechanical systems or the MEMS. They are also used in cancer therapeutics. Then we have the nanobots. Close to the scale of 10 to the negative 9. Nanobots of 1.5 nanometers across, capable of counting specific molecules in a chemical sample. Usually, these are capable of replication using environmental resources. What are the applications? Detection of toxic components in the environment, in drug delivery, in biomedical instrumentation, wherein they are used also in the field of medicine. Then we have the approaches of nanotechnology. It can be top-down method or the bottom-up method, analyzing the given illustration from bulk metal to powder. It means from complex to simplest. On the other hand, from bottom-up, we have the from atoms, the smaller one, to complex one. And when we are talking about bottom-up, in the bottom-up approach, different materials and devices are constructed from molecular components of their own. They chemically assemble themselves by recognizing the molecules of their own breed. On the other hand, when we are talking about top-down, nano-objects and materials are created by larger entities without bouncing its atomic reaction. Usually, top-down approach is practiced less as compared to the bottom-up approach. And what are the materials usually used? We have zinc oxide, silver ion, aluminum silicate, gold ion with the corresponding uses. Nanotechnology has also its application. When it comes to energy, medicine and drugs, nanobiotechnology, nanodevices, optical engineering, defense and security, bioengineering, cosmetics, and nanofabrics. Some of this will be discussed. Nanotechnology in drugs or cancer. They become localized at the disease site. Example of this will be cancer tumor. Then they release medicine that kills the tumor. And this can be currently treated by radiotherapy or chemotherapy. And nanobots can clear the blockage of arteries and provide new options for drug delivery and drug therapies. Wherein these nanobots can enter our bloodstream, especially the arteries, if these are blocked by fats and other materials. Then we have nanotechnology in fabrics, where the properties of familiar materials are being changed by manufacturers who are adding nano-sized components to conventional materials to improve performance. So they are used in making water and stain-repellent clothing, in manufacturing bulletproof jackets, which are being used by the men in uniform to protect themselves against bullet. Then, in making spills and dirt-resistant, antimicrobial and antibacterial fabrics. We also have the nanotechnology in mobile. Morph, a nanotechnology concept device developed by Nokia Research Center and the University of Cambridge, UK. The Morph will be super hydrophobic, making it extremely dirt repellent. Hydrophobic means fear of water. It will be able to charge itself from available light sources using photovoltaic nanowire glass covering its surface. At the same time, these are capable of stretching. They possess the property of being flexible. They can be bent, stretched, and folded in any number of conceivable shapes. Next in line, we have the nanotechnology in electronics. Electrodes made from nanowires enable flat panel displays to be flexible as well as thinner than current flat panel displays. Nanolithography is used for fabrication of chips. The transistors are made of nanowires that are assembled on glass or thin film of flexible plastic. We also have the e-paper or the electronic paper displays on sunglasses and map on car windshield. By the way, when we are talking about nanolithography, it is a growing field of techniques within nanotechnology dealing with the emerging of nanometer scale structure. Then we have the nanotechnology in computers. The silicon transistors in your computer may be replaced by transistors based on carbon nanotubes. A carbon nanotube is a molecule in form of a hollow cylinder with a diameter of around a nanometer, which consists of pure carbon. The size of the microprocessor are reduced to greater extent. Nanorods is a upcoming technology in the display techniques due to less consumption of electricity and less heat emission. Like what I have said a while back, size of the microprocessors are reduced to greater extent. A memory store can be used as a single component memory cell in an integrated circuit. Magnetic nanowires made of alloy of iron and nickel are being used to create dense memory devices. Aside from this, we have the advantages of using carbon nanotubes. First, faster and smaller in the sense that carbon nanotubes can be used to produce smaller and faster components. This will also result in computers that consume less energy and high-speed and high-capacity memory that allows circuit to be more accurate on the atomic level. Other uses: cutting tools made of nanocrystalline materials such as tungsten carbide, tantalum carbide, and titanium carbide. Then we have the silver nanocrystals, which have been embedded in bandages to kill bacteria and prevent infection. Then we have the nanoparticulate-based synthetic bone formed by manipulating calcium and phosphate at the molecular level. Then we have the aerogels, which is the lightest known solid due to good insulating properties, is used in space suits and are proposed to be used in spacecraft. It has insulating property, the sense that they are not good conductor of electricity. That's why they are being proposed to be used in spacecraft at the same time in space suits. You have learned the applications, uses, advantages of nanotechnology. This time, we'll be dealing with the possibilities for the future. Nanotechnology may make it possible to manufacture lighter and stronger materials. The future of nanotechnology could very well include the use of nanorobotics. These nanorobots have the potential to take on human tasks as well as tasks that humans could never complete. For instance, the rebuilding of the depleted ozone layer could potentially be able to be performed. The work to be done by humans will be replaced by nanorobots. There will be an entire nanosurgical field to help cure everything, from natural aging to diabetes to bone spars. There will be almost nothing that could not be repaired eventually with the introduction of nanosurgery. This is very useful, or rather helpful, when it comes to the field of medicine. Then we have the pitfalls of nanotechnology, or what we call as the disadvantages. Nanoparticles can get into the body through the skin, lungs, and digestive system, thus creating free radicals that can cause cell damages. Once these nanoparticles are in the bloodstream, they might be able to cross the blood-brain barrier. Then, this might affect the brain. The most dangerous nanoapplication used for military purposes is the nanobomb that contains engineered, self-multiplying, deadly viruses that can continue to wipe out a community, country, or even a civilization. This is really dangerous in the sense that it can destroy the community, but rather the whole civilization or the whole world. Nanobots, because of their replicating behavior, can be big threat for gray goo. When we are talking about this, it is a hypothetical global catastrophic scenario involving molecular nanotechnology in which out-of-control, self-replicating machines consume all biomass on Earth. The additional disadvantages are the following. The waste release while making the materials might cause air pollution. This will affect the health of the people, not only the people but also the animals and the plants around the surroundings. Agricultural countries will lose their income as nanotechnology will take over, in the sense that the work that should be done by humans will be replaced by nanorobots. It has very high initial investment cost along with high manufacturing costs. This only means one thing: even though they are very small, still they are very expensive. Therefore, the bottom line of this topic, the next big thing is really small. These are the references I've used. Thank you very much for listening. This is Maria Monica de la Cruz signing off.